Hi, come on in.
How did you get started in optical coherence tomography?
Yeah, so I started my undergrad training in physics, and soon after I joined college, I joined this photography club, and it's called YASP, Youth Amateurs Photography Association. I made a lot of friends and took a lot of nice pictures, and then I was really into imaging and optics and decided to join the physics department at UPenn to work on optical imaging.
What's the coolest thing happening in your lab right now?
Let me show you. So this is one of the latest chip we're making, and actually you can see here we have this black region, that's a photonic chip, and you see many structures in it. What we're doing right now is to feed light through the fiber and couple it into the chip. And inside this chip, we can make lasers on it, and we also integrate the photodetectors. So I have the entire OCT circuit fully integrated on this chip. So on the screen, it looks big, but if you look under the microscope, it's only like about 3 by 5 millimeters in size.
Explain optical coherence tomography.
Optical coherence tomography, in short, is called OCT. And you can think of it as an optical analogy of ultrasound. And ultrasound, you can see through the tissue, you can see the internal organs and structures. And with OCT, we're using light. And we are using near-infrared light, very low power, less than a milliwatt, to put into the eye. And you can use that to get the three-dimensional structures of the eye.
The ARPA-H grant is a really big deal. The first one that WashU got. What are you most excited about?
So we are very excited to start this ARPA-H project, and what it does is allow us to really change the current OCT system, which is large and bulky, and only those major eye facilities that has it. And what we're doing is integrating everything onto tiny little photonic chips the size of your fingernail. And this will allow the system to be more compact and widely available, at the same time at a much lower cost.
What's your favorite thing to do when you're not at work?
Oh, so we have a dog. We like to, my wife and my family, we like to work the dog. Her name is Nova. She's 4 years old.
What do you think is the key to collaboration across disciplines?
Communication is the key. And in order to understand each other, we actually need to learn the other language. And but the exciting thing, the great thing is that there are a lot of opportunities at the boundary of different disciplines. So if we can keep learning and learn the language and learn the problems or the challenges of different fields, we can find new opportunities. And for also, I think it's important to appreciate the expertise and experience of our collaborator in their own field, and then we bring complementary expertise together to make something new.
What advice would you give to aspiring engineers or young scientists who want to get into engineering or STEM fields?
Yeah, so engineering is exciting because we constantly make something new. And I think my advice is don't hesitate to try something you haven't done before. And also it's like keep learning, and this will, lifelong learning is key to become successful in any society.
Star Wars or Star Trek?
Star Wars, no doubt about that. So